Okay, what I want to do is talk about implementation. That is the focus this week, and a little bit of refactoring. But I'm going to focus on the implementation of library in the next 30 or 40 minutes. And also, that is the focus of the class exercise. You need to understand that code very well so that you can do your implementation more easily. And also, in your second exam, the programming problems will be on that particular version, what is actually available on the web. The class exercise, class project 1, version 1. So there will be 2 programming questions, one to modify an existing functionality, and the other is to add new functionality. If you don't understand the implementation, it's going to be very difficult. So I will now go over some of the aspects of implementation. I want to focus on things that are not in the design chapter, things that are on top of the design in some sense. Okay, so let me, actually it is covered in the videos, I know, but I would like to emphasize it again so that you understand those changes that were put in for the sake of clarity or the sake of consistency and code safety. Okay, so that is what I would like to do first. Focus on maybe 3 or 4, 5 classes, or maybe, and then touch upon a few other things. So let me go ahead and share the Eclipse window. I'm not using any PowerPoint, or I'll also try not to use any of the the whiteboard or anything of that kind. I'll try to explain everything using the Java code from the implementation. So this is I'm going to look at the Java code. So what I want to start off is with this class called data transfer. This idea of a data transfer object is not very new. It is like 2000 or so. It is used for transferring information between 2 objects that are usually geographically distant. For example, you might have a client on your machine and a server on a machine in Seattle or New York or wherever, and you want to send information back and forth, and you don't want to send too many messages because that will be slowing down your system. You don't want to keep on sending messages back and forth. It requires so many levels of transfer even in your computer, and it has to go through so many other computers on its way to that distant site, and it has to also travel several layers of software at the destination. Instead, if you send all your stuff in one object, you are getting more bang for the buck. So what does a data transfer object contain? It's up to you, right? Whatever you want to send back and forth, that's the idea. So there is no real, what do you call, you can't really say it has to contain such and such things. It depends on what you want to transfer, right? So let's assume that we want to transfer book and member information. I mean, that is very common in this system probably. You want to request data that about books or members. You also want to send information about book and data. You might also have other things, but then we will have subclasses of data transfer. So the data transfer contains all the string fields of book, corresponding string fields here, and string fields of member, the corresponding fields here. And you have getters and setters. That's it. It's very simple, actually. So there is nothing to really explain about these getters and setters. But there are a couple of other methods, like if you want to set all the member fields, if you want to copy from a member all the string fields to the corresponding fields here, you have a method like this. So instead of calling set member address, set member name, blah, 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 all that, you can just call set member fields, ship in a member object, and then everything gets copied. Similarly, we have a method called set book fields, and we pass a book object, it gets copied. And one thing that you will note here is none of these fields is ever null. So even if I don't have anything in a for a field, like there is no borrower for a book, I am going to put none over there, so that whoever gets this is never going to crash because there is a null reference. That is another what do you call another consideration that people in software engineering want to guarantee, that you don't send null objects to your to systems outside of yours. Maybe it is okay if you knew among yourselves where nulls are going to come, etc. But as a rule, when you are sending stuff outside, don't send null pointers. That is considered bad design, because you have to then check for nulls, etc.
Professor, quick question.
Mm-hmm.
Does that is there a trade-off there about folks not doing proper error handling when they should?
That is a good point. Yes, but one consideration is that's a very good point. I mean, why don't you debug your code? That's a good question. But people generally believe that it is not fair to send null pointers back, because null pointer, what does it mean? There is no data. But then a null is not a good indicator of absence of data. It should be more like a Boolean or something, or you could put in a message saying there is no data or such thing. It is arguable, I agree. It is, one could always get rid of all these errors by putting checks. Yeah, it's a debatable issue, yes.
If I'm going totally off the rails here for class, please stop me. But I just think one of the strengths of Java and the reason we can do things like actually make efficient data structures and whatnot is our ability to use references within the code, right? So I almost feel like if you don't want that, shouldn't you just write something other than Java or something? But yeah, I'm way off the rails here. I'll be quiet and we can move on.
Okay.
But
That's okay. I mean, really speaking, one should be careful with anything that you get. Like if it is null, you should be, or you, I mean, when you expect a reference, you should be prepared for null. That is a good argument to make. Yeah, I don't disagree with you. But many people feel that you shouldn't be sending back null. So if you want to take that approach, then this is what you would have, this kind of stuff. Or you could put something like, instead of none, you could say no borrower.
Sure.
Or
well, thank you for indulging my question. I appreciate it. I'm sorry
yeah.
to take us on a tangent.
No, this is perfectly fine. I mean, you have a very valid point. I mean, I don't disagree with it even one bit. I mean, why would you not worry about null? But this is also this is uh, what do you call, something that the really big shots in the field, like the Software Engineering Institute at Carnegie Mellon, those kinds of people say you shouldn't be doing these kinds of things. Well, if you want to, what I am trying to say is something. What I'm trying to do here is something that prepares you for a situation where your boss says, no null pointers in this organization. Okay, then I don't want you to get a shock, right? So that you cater to a different school of thought. That's the idea here. So you could probably say book due date not applicable, borrower not borrowed, kind of stuff, so that when if you happen to display it, it comes off as something meaningful, perhaps. Okay, now it is, oh, one other thing, I mentioned this in the video. You would typically use this data transfer object when you want to send a single message instead of a large number of, or a, or several messages. Okay, instead of that, you're just sending one message. But if you think about the library, what we have here is not going to be exactly how it is in a real system. The user interface would be probably a graphical user program on your machine, or like an app on your phone, or it could be your browser, and the library server would be miles away. And so when you actually implement this, it is not going to be that, it is going to be the case that everything is on the single machine. So this is is a very valid thing to do. And another reason why we want something like this is, if you look at all the methods of library, there are most of them have string parameters, and it is very difficult to remember the order of those parameters. It is uh, it is likely to provide or to cause bugs, because you ship the string parameters in the wrong order, and things don't work. So it will take you a while to get those things debugged. Whereas if you put everything into an object like this, you have to use things like get book title, or set member address, kind of stuff. So you are not really looking at the position of a parameter, you are actually looking at the method name, and that is less likely to cause a bug in your program. And we are going to have two subclasses of this. One is result, and the result has a number of constants that are self-explanatory. And this is an extension of data transfer. So this is to indicate a result. So I have a field called result code. And this is also accepted in the field to have some kind of return code, or some kind of indication as to what happened to your request. This is the result. So this is the extra field for result. So everything that you have in the data transfer object, which is things like all the book fields and member fields, copies of those string fields, plus a result code saying what happened. What I have done in the library is, if everything went okay, the result code is going to be operation completed. Otherwise, it is going to be somewhat more specific as to what the kind of error is. Sometimes I am unable to say what it is, then I simply say operation failed. The other thing is, this was a very recent change. I did this only last week or around that time. And how these fields are set may not be completely consistent, but some of the fields may be none. For example, if you're trying to add a book, and if we didn't go through for whatever reason, it has never failed for me, then all these fields are none. But if you can't place a hold, what should I return? A member requests a hold, and suppose that hold cannot be placed for whatever reason. What should I do? What should I do with these fields? If the member couldn't be found, I put none, I believe. But then if the book couldn't be found, maybe the member fields would be valid and the book fields will not be valid. One can keep on arguing as to what you should be putting if something went wrong. So you might disagree with me in the setting of some of those fields. And if you think that what I have done is completely wrong, please let me know. I would like to fix it. But if it is something arguable, then I don't know what to do. Okay. Then we have another subclass of this data transfer, and that is called request. Because not everything is covered by these. When you request, there are a couple of other things that I want. One is the hold duration, which is never in a return. It is never in the result, but when you request the placing of a hold, there is a hold duration. And by the way, my co-author of the book tells me that when you do interlibrary loans, one of the fields you need to fill out is the hold duration. That is not needed after such and such date. And this is a date for which you need the transactions. So they are in the request. The request is a singleton. Okay. So that is one thing. Then let's go to something very much simpler. That is the library. The library is pretty long. For one thing, it has all those facade methods. Also, what I did this semester was put the library as an inner class of, the catalog as an inner class of library, as well as the member list. Both are inner classes of library. They used to be singletons, but I removed the singleton pattern from these because it is very difficult to get singleton done when you have an inner class. Java doesn't like certain things, so it was impossible. Why did I make these inner classes? Can somebody guess? Or maybe it was in the video. Can somebody say, why did I make catalog and member list inner classes? What would be a motivation for doing it? They were singleton classes, independent singleton classes, but they are non-singleton inner classes now. Any thoughts? Yeah, the reason
why the change away from singleton?
No, why are they not independent classes? Why are they inner classes? And or let's or put it slightly differently. Let me pose the question slightly differently. What would be a drawback if they were independent singleton classes? What could be a danger? For example, suppose you have catalog as a singleton class, and you say catalog.instance, and you get the catalog instance, and then you can perform operations on the catalog. That's what I had actually at least 2 weeks ago, and we realized that is a real danger. The danger is if you make catalog a singleton class and it is independent, then somebody from the outside, like user interface, can get that instance of catalog. It can write catalog.instance and then start doing whatever it wants with the catalog member, the catalog. You can delete books. It can modify things inside the catalog. So we didn't want to expose the catalog to the outside world. And the design of the library is such that no class other than library has anything to do with catalog directly. But when I moved catalog inside, I couldn't make it a singleton anymore because of the way Java works. At least I couldn't find a workaround. When I put a private static thing here, it wanted it to be final, etc., etc. So I had some difficulties. So I decided that it is better to hide catalog from the outside world than make it singleton. If I made it singleton and then put it outside, that would be a really risky thing. Same thing with member list. Okay. Now, there are two iterators, as you must have seen. These are not, this is not there in the design. So when you want transactions on a certain date, you have potentially a large number of transactions within the member class. So there is a collection and you have a number of transactions on different dates. And suppose you want the transactions for a certain member on a certain date. Then what we want in user interface is the ability to get an iterator. So it gets iterator transaction, library.get transaction, and we pass in a request. So most of these facade methods have just one parameter, have exactly one parameter. Some of them don't have parameters, a couple of them. I will show you them. Actually, I added two extra methods. I don't know where they are now. Yeah, like getting the list of all books and getting the list of all members. This is not part of the analysis, but I just added them as extra methods, and we will get to those. So they don't require any parameters when you go to the library, like library.get members, library.get books. They don't have parameters. But most of these other library methods have a single parameter of type request. So when you want to get the transactions on a certain date, you get library.get transactions request.instance. And the request object contains the member ID and the date. And here we get a result, and that is an iterator to a transaction. And you iterate through that. But that iterator is not what Java provides, the JDK iterator. It is a different iterator. It is a filtered iterator. A filtered iterator is a design pattern. What it does is it is, of course, an iterator, but it gives you only objects that meet a certain criterion. So filtered iterator implements the iterator interface for transactions. So this one will give you a transaction when you call next, and has next, of course, is here. So what does the how does the filtered iterator work? Well, you give it an iterator to a transaction, right? So you have possibly all the transactions for a member, and then you give an interface. This is a JDK interface predicate. It is from Java, right? So predicate is an interface. It is called a functional interface because it has exactly one method. An interface that has only one method, one abstract method, is called a functional interface. And predicate is one of them. It has exactly one abstract method, and that is called test. So this is the test. Predicate object has a test to see whether a certain transaction must be picked or not picked. So when you create a filtered iterator, you say from where all your transactions are coming from and what condition you must apply to select a transaction. So you simply store those things here, and this particular method lands you on the first transaction that meets this predicate, meets this condition. A predicate object simply checks whether a certain transaction meets a certain condition. So get next item is a private method here. And what I do is I use this iterator object or reference, or however you want to call it. I keep checking if there is one more transaction. If there is one more transaction, I pick it, and then I check whether the test method of the predicate object on this particular transaction object is meeting the criterion, whatever that criterion is. Test has some implementation. It may be checking whether the transaction is on a certain date, or it may be checking whether the transaction is corresponding to a book being issued. You can do whatever you want in this test method, but you have to supply that condition. And if so, if it meets that criterion, this simply stops at that point, it returns. So this item is satisfying this test. So this makes you land on the first item that satisfies the predicate. And then when you call has next, it will check whether that item is null or not. And if you call next, if there is one more transaction, if has next is not false, it will come here and store that item in this return value and return it. And then it moves you to the next transaction that satisfies the test. So it calls this again. Eventually, you will run out of all transactions and you will return false here. So that is that. But the way it is called is probably something, I know some of you have seen that in the literature. Some of you might be wondering what it is. So this is worth looking at, because you are going to see this again and again all over the place as you are looking at Java code in the various examples that you can see. So it is important to understand this. Look at this method. It's very short, but there is a lot going on here. Iterator transaction, get transactions on date. So given this date, like February 5th, 2021, give me the transactions that happened this date for this member. Okay, all right. I need to create a filtered iterator because I don't want to give back an iterator that gives you every transaction. So the filtered iterator uses all the transactions that the member has generated. And so this has to be the first parameter of the filtered iterator, the iterator to a transaction. But the second parameter, if you recall, go to the filtered iterator again. I'm wondering where it is. Okay, here. The second parameter is the predicate object. The first parameter is, of course, the iterator to a transaction. So we are passing all the transactions in iterator to all the transactions. The second one has to be an implementation of the predicate interface. So you have to provide a test. So how would you write that? You would write things like, I think it is in the video too, but I'll briefly do this, but not completely. It is in the video. So you would actually write public or private, whatever, public class, my filtered iterator. I'm making it very, you shouldn't be spelling like this, but I am doing it so that I can do this fairly quickly. Implements predicate transaction. I want to get a predicate on transaction, but then this says I haven't implemented all the methods. So I need, and actually I have to import the predicate. Then I have to implement the methods. So I need to provide an implementation of test. What should be the test? Given a transaction, I should check whether T dot on date is equal to a given date. So I would write things like, if T dot on date, whatever date, or maybe return whatever this returns, right? Of course, I haven't declared what this date is, anything, but this is the idea. I will simply check whether this transaction is falling on this date that I have in mind. So think about the predicate interface. I'm implementing it here, but remember the fact that this is a functional interface. It has only one method. So what the heck is my get transactions? Okay. So there is only one method, and this is the only thing that really is specific. Otherwise, Java knows that you will be creating a class, you will be naming it something, it will be implementing predicate transaction, you will have the method test, you have to have all that. And then this is the one that Java doesn't know that you have. So what I am doing here is simply putting this code, transaction.onDate, and the date that I have in mind. This is the parameter to the test method. So whatever is the parameter, I called it transaction so that it's a little more transparent. So whatever is the parameter to the test method, check whether it is falling on this date, which is here. So instead of writing a class like this and have somewhat bloated code, I'm allowed to write stuff like this, and this is called a lambda function. So you are passing some code as a parameter, apparently, but think about it as an object that contains this code in the test method, because Java is expecting a predicate object, so it knows that you are actually implementing the predicate interface, and you are implementing the code within the test method. This is the parameter to the test method, and this is the code that is to be checked. If this is evaluated to true, the test method returns true. If this returns false, the test method returns false. That is it. So you will see this kind of stuff, especially when you are handling events in a graphical user interface program. Some of you have used this in your second assignment, and this is what is going on actually. You are implementing an interface, and putting the most essential code that is in the implementation of that only method, because it is a functional interface. You cannot use it anywhere else. Okay. So that is filtered iterator. The next one is safe iterator, which is even more difficult to understand in some sense. But actually, I could have made this simpler, but I didn't. I was debating what to do about it. So I could give you a different implementation. I can post that as well. The safe iterator, what it does is it provides a copy of something. For example, if you want an iterator to book objects, you don't want to send back book references to user interface. You can't trust it. It is an outside entity, right? So you would like to send copies of the book information. So what you would like to do is send back those things in a result object. So we are obviously implementing an iterator, and what we are doing here is when the next is called on a safe iterator, it brings back a result. It is very easy to understand what this is accomplishing, although the code itself is not easy to understand. So if you call next on a safe iterator, it brings back a result object, and you can look at the result object and then see the fields of book or member, whatever you are creating this on. So one difficulty that you might have is maybe you don't remember the implementation of generic classes. So when you create a class, you can put a parameter here, one or more parameters here, and you generally put single capital letters. So I put T here to mean a type. This, I'm expecting this to be created either as book or member. So you would write new safe iterator and then put book or member. I will show you an example. Okay. Yeah, here. When you create a safe iterator, you specify what it is that you want to iterate on. Do you want to iterate on members or books? You specify that. So wherever T occurs here, they become that class. So if you put in book, this would be an iterator to a book, right? And when you create a safe iterator, you need to supply an iterator to book or member. So if you put in, where is library? Here. Okay. When you create a safe iterator with member, you need to give a member iterator here. And the second parameter has to be safe iterator dot member. If you put in a book, you put a book iterator, and then you need to put safe iterator dot book. Where do these things come from? Obviously, they are fields in safe iterator, and they are over here. They are final static fields. And there are two classes, safe book and safe member. I'll tell you why those are needed in a minute. So when you create safe iterator, you get the iterator to a book or a member, and this would be either book or member, and you can see both are of this type called type. The outside world doesn't have to know what these are or anything. To use it, you simply learn what you have to put. That's it. So the outsider doesn't need to know how this is related. If you use book here for T, then you have to put safe iterator dot book as the second parameter. If you put member here, you have to put safe iterator dot member as the second parameter. That's it. That's all a user has to know. But why is it needed? Well, let's see. The iterator is stored, so is the type, and obviously you need to implement has next and next. So what we are doing is we are going through let's say books. We are going through every book, and those books are given by this iterator. So is there one more book? Actually, the user gets results. Uh, there is one more result if there is one more book. That's it. So for every book, we get a book object in this class and then convert that to a result object or store that in the result object. So if there is one more book, what we do is we take that book object and copy it into a result object. So what is type? Type is going to be safe iterator dot book. So if you call type dot copy, where would the control go? Well, type book is of type safe book, and safe book is sitting here. So it will actually call the copy method here and copy the book into the result. So this object is expected to be of type book. It will be, because iterator dot next is going to be a book. So we cast it as a book and then tell the result to copy all the fields of book. That's it. And then we will return the result object, because the book fields have been copied into result and you send it back. So that is how it works. That is why we have this class called type, which has a single method, abstract method called copy, which is implemented by safe book and safe member. Instead of all this, we can get a simpler implementation if we get save, if you declare safe book iterator and safe member iterator, then some of the issues dealing with the code here would be improved, the situation would be improved. But then whenever you create a new class, whenever you have one more class that should be exposed, you will have to create a class outside. Whereas here it would be creating a class inside. So everything is localized here, whereas the problem is a little more spread to the outside world if you take the other approach. That is the trade-off. Personally, I would like to go with this kind of a design, because everything is confined to one place, and all that the outsiders have to know is that if you want a book, you have to pass this as the second parameter, whereas in the other case, I have to go and create a new class on the outside, whereas I know that I have to just do surgery here. That's I mean, one could argue about the advantages and disadvantages, but I will post an implementation where there are two classes, safe book iterator and safe member iterator, and this class, each of those two classes would be simpler, right? More understandable. But then I have to change library as well. So I will do that as well. Okay, so look for that sometime, maybe not until Friday, but I will try to do it on Friday. Okay, I'm having other things to do tomorrow and day after. Okay, I'm wondering what else is there to cover. Oh yeah, there is one little thing here, very simple. When you serialize the library, where is it? Here. You are creating a file called library data, serializing the library object, which will serialize all the fields. The two fields are, the two fields that matter are catalog and members, and they would both get serialized. So everything in catalog, everything in members will get serialized. So pretty much the whole library is now serialized except for one thing, and that is the field ID counter in member, because that is static. So this will not get serialized, and that is a bug. So I have a method called save, which would serialize that static field. So I'm calling that from here. Library here. No, I keep forgetting where those methods are. Okay, here. Yeah, I write out the library using write object, and then I call the save method of member, passing this object output stream so that the member can save its ID counter, and then I'm done. And when I retrieve the library, and then I retrieve the ID counter in member, because that is the order in which I wrote them. That is what I wanted to talk to you about. Any questions that I can answer at this time? You should be aware that every question in the class exercise is dealing with the code in this implementation. So the intent is to make you look at the code as much as possible, make you familiar with the code. Uh, so, okay, so that is the motivation. Any questions before I let you start the class exercise? Okay, then